As part of my day-to-day work, I look at a lot of student code. And I see really confusing things in student code. But more to the point, I see unnecessarily, gratuitously, needlessly complex things. And if you think this is the worst of it, you got a thing coming to you. So what's going on here? You don't even want to look at it. It's like, something like this, again, it kind of makes me wonder, have you no sense of dignity? Or have you no sense of shame? This is like, how can you put out something that is that inscrutable? Now, does it perform something? Does it compute something? Yeah. Does it compute the right thing? Well, it's kind of hard to tell when you look at it. So tell me some things that are confusing about this. Okay, so let us count the ways. So enumerate one or two. Okay, so or decrements came by one. Okay, so okay, there's another one. Okay, yes, there's a k, and then there's this k minus minus. Now, what's unsettling about this use of k and this k minus minus? Yeah, and is this k computed before or after that's decremented, right? Is it like after this has been decreased or before it's been decreased, right? That's an unsettling question. What's another thing? What is this? So if I were to eliminate this, suppose I had this in a printf, embedded in a printf. Suppose I were to eliminate that printf. I don't need it anymore. I don't need it to print something out there anymore. What would change? What is this thing actually updating? What is it changing? What is it modifying? Okay, it's modifying x, it's modifying k. What else is it modifying? The contents of whatever is pointed to by xp. Whatever xp is. I thought it was here it's modifying whatever it points to. Whatever unfortunate thing in life is pointed to by xp, it gets blocked. It gets cluttered, all as part of this expression. Now, when you first glance at that may not have been obvious. You kind of look at it like, what that? Okay, yeah, so you got to sort of start piecing it apart. Oh man, there's a right to that in there, and it's just not clear, ladies and gentlemen. It's puzzling sort of what's in there. And again, this is not as bad as it gets. It gets worse than this, and some of my students love, and third-year students just love seeing me react to their code. Because I get very animated, and I make utterances which are then recorded on YouTube that probably I should avoid. I'm glad that YouTube has a 18-year. Some of my utterances are not for choice use or what. So here's a possible rendition of this. So now let's split this up into a couple pieces. Instead of trying to pack it all into one. And by the way, there are people out there who just love to do this, especially with something like C, which is so sort of terse and so what they just love to pack it all in one expression. They love to sort of strut. Like somehow, they're really macho because they can put together these inscrutable C expressions. Have you folks ever looked up the obfuscated C contest? Oh man, you see poems written in C, totally uninterpretable, not because they're deep poetic nature, but because it's just hard to make sense of anything that's going on. But here, we've broken this expression up into some pieces, okay? And that's a good start. Eschew complexity. Avoid complexity. If you don't require it for some odd reason, some limitation in the language, try to get rid of it. Okay, so first here we determine, first sort of look at this comparison. And we say, okay, 2 times k less than m, and if so, then we'll update xp with this thing, otherwise we'll update it with this thing, and then at the end we'll update this, this x, okay, which is updated with something that after all is stored in xp. So we add to x by that. So that helps a bit, but even there, it's awful easy to kind of look at this and not maybe immediately pick up that k is changing here. So another thing would be to separate that out into a separate line here. And ladies and gentlemen, this gets to this principle, I'll come back to this at some point, but it gets to this principle of separating out the so-called side effects, things that change something, things that modify something, things that if you eliminate that line, you know, things will change from each other and from things that just compute values. So for example, this if statement has a 2 times k equal. We could have in principle have modified, you know, k there or what have you. But if we're going to modify k, do so at one place it's clear and it's in its own line to itself, so we can see, okay, there's the modification of k. This is simply using d of k. I don't have to worry that it's getting changed at one time, which adds to sort of cognitive overhead. This lays it out more clearly. Okay, I'm modifying k after I'm using it here to get this value. Now, this code sort of unpacks this expression to several lines. And someone might say, well, it's more lengthy, it's more verbose. But how many people feel this code is easier? It's not perfect, but it's easier to understand than that code up there. No? Okay. How many people would just like to get rid of this out black spot? Well, there's a reason you might want to you might have that Macbeth hold to you. And the reason here is that there's still a lot of things that are really cryptic here. Like what the heck is D? And this 2, what does that have to do with anything? What does n minus n mean anyway? You know, is n the height of Mount Everest in fathoms, and you know, n is the number of armadillos in, you know, El Paso County, or are they some meaningful thing like m is you know the count of students in the class or in second year, and n is the total number of students in the class? That can be made much clearer by appropriate naming. And this whole thing with 2 times, I mean, that's for the birds. What is 2? It probably says some ratio between something and something else. Let's give it a name. I mean, sticking in it as 2 there, you know, maybe it's because it's 1 minus, you know, 3, which is the number of different types of, the number of computer systems that have to be joined together. And we're just putting it at 2 because it's 1 minus 3. If we want to change it to we have 10 computer systems later, we'd have to change it to 9, but we wouldn't know that by looking at this code because its origin is not clear, its provenance is not clear, the meaning behind it is not made clear. It's just 2. And why 2 as opposed to anything else is just not made clear. So giving it a name, or if it depends on something, if it's 1 minus something else, you know, then having that derivation made clear elsewhere in its name should be clear. Actually putting it in there, something minus 1 times k or what have you. So this is getting better at least it's less totally inscrutable. At least you can kind of piece apart what's going on here in a systematic way. Whereas above, ladies and gentlemen, as they said in King Lear, that way lies madness. I'm trying to put it all into one line. If you don't believe me, go take a look at the obfuscated C contest. That is indeed got lots of madness in it. Okay, so some principles, right? Clear, not clever code. Don't try to strut your stuff that you're a C stud and you know the precedence of all these things, and you'll make people cry with your code. I mean, there's no honor, there's no glory And in fact, you'll find yourself being brought to tears sometimes, late at night as your code doesn't run. So don't try to be a He-Man about it. Try to remember to have self-respect here. I mean, ladies and gentlemen, wipe your butt. Just try to put in the effort to kind of keep things clean, hygienic, clear, because you're going to be needing to share it with others. You're going to be needing to deal with it yourself. And if it's all crufty and confusing, you're going to be just asking for bugs to pop out at you when you have the professor looking over your shoulder or something like that. And if you don't believe me, we just had, so yesterday we have a fantastic system that's been built up and starting to be used worldwide. And it's very, very robust. And we had a demo of it yesterday, just a casual demo. And the student in charge of it went to demo it in front of a group, and first button he pushed, crashed. And they were using it too, and crashed for them too. And this was in the middle of a phone call with long distance people, and it was really embarrassing for him, embarrassing for all of us. And it's an extremely robust system, lots of testing and so on. And if even something like that can fall prey to this, believe me, if you have that sort of dirty code there, you're going to be seeing this all the time. And it's not going to help in terms of the stress levels pretty well. So remember, clarity is not the same as brevity. Something can be short, particularly in a language like C, be totally inscrutable, like this sort of ugliness. Be very careful with side effects. You can put this into your code in C, and in this case, actually, it doesn't cause, the ambiguity doesn't cause a big problem. But you can have a single expression with multiple side effects in the same thing, I here. You don't know which occurs first, which occurs later. But the best practice here is to separate out the side effects from the expression. Don't have side effects, these so-called plus pluses or plus equals or whatever, even though you can do them, don't litter them all through your code. Because the order of execution of these different things, among other things, is not clear. It's not clear, for example, in this previous expression, is this K determined, for example, is this K determined before, this thing, this one actually is, because it has to be to determine which one of these is executed. But if there were another component that depended on K, it wouldn't be clear which thing executed first, for example. Or if we had a manipulation in here involving XP, there'd be cases where it's not clear which is executed first. So you got to be very careful with side effects and generally separate them out from expressions. This is highly actionable advice, especially for the first problem set.